Hello, so this is section 6.2, and we've been looking at relations. So in this section in particular, we're going to look at how to represent a relation with a graph. Okay, so this is not a typical graph that you think of in algebra, sort of XY axes, but we're looking at sort of like a arrow diagram, okay? We're going to look at the definition of a digraph. So a digraph is a directed graph. It consists of a set of vertices or nodes together with a set of E of ordered pairs of elements of V called edges. Okay, so V is the set of all the vertices, and those are usually like given names, numbers, or letters. Okay, and E is the set of vertices connecting those nodes or those vertices together. Okay, so the vertex A is called the initial vertex, if that's where I start the graph. Sometimes the starting point is important, sometimes it's not. And B is called the terminal vertex. So you have an edge. An edge is represented by a coordinate point, AB. So basically it gives you the initial, the starting point, which is A, and B is the terminal point, okay? So we'll see that sort of digraphs are directed graphs where the starting and ending point matter. You're going to have an arrow pointing from A to B, okay, so from the initial to the terminal. Sometimes the direction doesn't matter. Or you can sort of eliminate the arrows if it's bidirectional, but we're going to start by looking at these digraphs, these directed graphs. So let's look at an example. We'll see how to draw it. So we're going to draw the directed graph with vertices A, B, C, D, and these edges right here. Okay. So to do that, you're going to start by drawing dots for the vertices. And the configuration of dots is not really that important. You can sort of put your dots anywhere. I tend to just put mine in sort of like a square or a rectangle, or sort of if you have more dots, sort of just kind of try to place them so it's fairly clean looking and edges don't cross each other too much. Although again, sort of it doesn't really matter where you place your dots. Okay, so what matters is the relationship between the vertices. So let's say I call this A and B and C and D. Okay, so AB, this edge, tells me that I'm going from A to B, A being the initial, B being the terminal. So we're going to draw an arrow from A to B. All right, so basically this is sort of the important information here. It tells you how they're related. So it tells you how the set of A, B, C, D as the inputs are related to A, B, C, D as the outputs, okay? And then A goes to D. So there's an arrow going from A to D. B goes to B. All right, so this is represented by a loop. So you have a loop with an arrow. B goes to D, okay? And I've been drawing things as straight edges, although that's not important. So it could be straight, it could be curved. So it's just the important information here is that B is going towards D. And C goes to A. So there's an arrow that way. C goes to B, arrow this way. And D goes to B. So D goes to B means that there's an arrow going this way. So you see there's like two edges from B to D going both ways. Okay, so let's see if I can make the arrows a little bit more noticeable. So this is the arrows going this way. All right, cool. So this is a digraph. This represents this relation between the set, input set ABCD and the output set ABCD. Okay, so digraphs, typically you write when it's a relation on a set, so kind of going from set A to itself. All right, so let's look at the next example. All right, so we're gonna draw the digraph of this relation on the set 1, 2, 3, 4. So this is our set of vertices, right? And the relation, the ordered pairs, are the edges, and they tell us which way to draw the arrows to show the direction of the relationship. Okay, so let's draw the vertices. I'm going to have 4 dots to represent the vertices. I'm going to call them 1, 2, 3, 4. Again, it doesn't matter what configuration you draw them in or what order you draw them in. The important information is the arrows and the direction of the lines and the direction of the arrows. Okay, so 1 goes to 1 means that you have a loop. 1 goes to 3, 2 goes to 1, 2 goes to 3, 2 goes to 4. Now 3 goes to 1. Okay, so 1 went to 3, but 3 also goes to 1, so there's another edge with the arrow pointing the other way. 3 goes to 2. 4 goes to 1. And we put the arrow here to see it better. And that's it. Okay? So you kind of look at all the coordinate points and draw the arrows pointing from the initial vertex to the second, to the terminal vertex. All right, let's now read a digraph. Okay, so here's a digraph represented here. And we want to see what ordered pairs are in the relation are represented by this digraph. So first of all, I can see that the relation is on the set 1, 2, 3, 4 onto itself. And I can read the ordered pairs by looking at each of the vertices and seeing where the arrow is pointing to. So for example, 1 is pointing into 3. So 1, 3 is a vertex. And 1 is pointing into 4, so 1, 4 is another one. Okay, now let's look at the 2, vertex 2. So 2 is pointing towards 1, so 2, 1 is there. 2 has a loop onto itself, so 2, 2 is there. 2 is pointing towards 3, so 2, 3 is there. And 2 does not go into 4. Okay, good. So let's look at 3. 3 is going into 1. 3 is going into itself. 3, 3. And 3 does not point towards 4. Okay, so now let's look at the 4. 4 is going into 1. 4 is not going to 2. 4 is going into 3. And that's it. Okay, so just go through each of the vertex and see any arrows that are pointing out of it. Then you can write a coordinate point to, with that being the initial and your ending vertex being your terminal. All right. Okay, so this is this section, fairly short one, just to get a feel for drawing directed graphs diagrams of relations.